Hi, this is Irv Shapiro with Make with Tech, and I apologize for my gravelly cowboy voice. I'm getting over a bit of spring COVID, but I've put off making this video about the Creality Hi Combo for much too long, and so I need to get it done. So today, we're going to talk about a really very interesting printer that Creality sent me at no charge so I could do a review. They sent me the printer, they sent me the Creality Filament Management System, and a handful of rolls of filament that had been encoded so they're automatically sensed by the filament management system. Now, that said, one of the things that was most interesting for me about this review is this printer just works. We've reached the remarkable point where 3D printers in the consumer space that are priced for a few $100s now work like appliances, like your microwave or your sewing machine or your oven or your range top. And that's going to open up 3D printing to a new group of people who don't want to tinker with the hardware all the time to get really quite remarkable results. Now, I must say, this printer combo is not perfect, and I will point out a number of issues, but one of the issues I did not have is prints did not fail. They weren't all perfect. You can see all the stringing on this model, but they didn't fail. They completed successfully. And one of the other things that's so interesting about this combination is it makes it very practical for anyone to complete multicolor prints. Now, not any multicolor print. This print was not printed on this printer and would not be suitable for this printer. And in this review, I'll be spending a lot of time talking about color 3D printing, when it's practical, when it's not, what this style of 3D printer with a filament management system is capable of doing, and what it's really not designed for. So stay tuned and let's learn something together. Let me set the expectations for this video. This is not a detailed review of the Creality Hi and CFM. While I'm going to talk about them briefly, instead, I'm going to spend more time talking about printing in color and why you would and why you wouldn't, and which type of color prints work well with a material management system from Creality or any of the other 3D printer companies. To complete this picture of 3D printers at the consumer level becoming more like appliances, let's look at the current line of 3D printers from Creality. Let's look at this slide together. The printers listed on the top in blue are all the actively selling printers. And then there are many, many printers down below. I've been covering 3D printers for over 6 years now. My first 3D printer was a Prusa MK3. And then my second 3D printer was a Creality Ender 3. Very, very different printers. One printer sold for almost $1,000 and took hours and hours to assemble. And the other sold for about $250 and took about an hour to assemble. Well, Creality has evolved from a company that's targeting hobbyists to a company who's now targeting both professionals and serious users of 3D printers. Now, they might be hobbyists still, they might still be doing it at home, but they're interested in a more professional solution. All of the printers on the top section, that's the K1, K2, K2 Plus series, the Creality Hi that we're going to talk about today, and the Ender 3 V3 that I've reviewed in the past, are Klipper based. Let's talk about that for a minute. In order for a 3D printer to process and produce a print, any print, it needs instructions. Those instructions are in the form of something called G code, a format that was originally developed for CNC machines. And so you need a computer in the 3D printer. That computer or that controller interprets the G code and tells the printer what to do. Well, up until the last few years, the majority of consumer-grade 3D printers all used a wonderful open source solution called Marlin. Marlin ran initially on 8-bit controller boards, that's very small computers, and then was upgraded to work on 32-bit boards. But it's written in C. It's a difficult program to maintain and support because it was originally designed to work on very small computers to keep the cost down. So when you optimize for space and speed, sometimes the program becomes more complex. So a few years ago, another group of open source advocates created a new solution called Klipper. Unlike Marlin, which was written in C, Klipper was written in Python, an easier and more supportable language. And it assumed you had a powerful computer. Now, it assumed you had a powerful computer for the hard part of 3D printing, but it still relied on a microcomputer, a very small, fast computer, for controlling the physical motors, the temperature of the heating element, for sensing the temperature at the hot end. And so the Klipper environment really consists of two parts: a microcontroller part that's a small program that you normally don't have to modify very, very much, and a much larger, complex ecosystem of software that's used to do the hard things. What are the hard things? Well, when I'm printing this print, I have to move the print head. How do I decide the optimal path to move the print head to get both the best quality and the highest speed? How fast can I move that print head without causing vibrations that cause ghosting and other artifacts in my print? How fast do I have to extrude the filament so that I get a clean extrusion, but so that I don't get lots of stringing like I saw on this print? All of those calculations are very, very complicated. And in the Klipper environment, because it's Python based, a range of people can easily participate in optimizing that code. Most of the current new 3D printers for consumers that start at about $250 or above use Klipper. Now, in addition, Creality's made another change. They've gone from just producing the printers and using a third party to slice the print. Slicing is the process of taking a 3D object and preparing it to print on a 3D printer, producing the G code. And historically, they used Cura. I was a big fan of Cura. I used Cura for years. But now they've moved to their own solution they call Creality Print. Originally, Creality Print was also based on Cura, but now it's based on a new slicer, an open source slicer called Orca Slicer. And Creality Print is really a wrapper around Orca Slicer that's been optimized to make it a little bit easier to use with your Creality printer. So for example, if you're using the Creality Print software from Creality with a Creality Hi and a Creality Filament Management System, it will auto-map your filaments. And I'll show you a demonstration of that a bit later. Now, I'm sure Orca Slicer will add this in the future, and these two slicers are probably going to leapfrog each other. But I'm right now, for most consumers, recommending you start with Creality Print because it's more of a seamless environment. Creality is producing an integrated slicer that works with your printer. But they produce more than that. Let's look at this slide. They also have a cloud environment where you can go to that cloud environment and you can select things to print. You can select from thousands and thousands of models. Now, many of the models, I'd say the majority now of the models, are models you have to pay for, where an author has posted the model and you pay them a couple bucks to download the model. But in that cloud environment, you also can use a slicer in the cloud. And so you could use just a browser, Creality Cloud, and your 3D printer without ever using any desktop software. Alternatively, you can use the Creality app on your phone. And in fact, the Creality app on your phone makes it easier to install and set up your 3D printer. So you have the Creality app, you have the Creality Cloud, you have Creality Print, all working together. Do they work seamlessly? No. Creality is still better at making hardware than they are at making software. But it's getting a lot better. And interestingly, much of this new Creality software, specifically Creality Print, are open source. So that means they're inviting the community to participate in working on this software. We're going to look at that all a bit together in the next few minutes. Let's talk about color printing. This print and this print are very different. I could print this print on the same printer I printed this print, but I cannot print this print on a Creality Hi. At least not unless I want to take hours and hours and hours, probably more than a day, to print this print. And the reason is there are different ways you can configure a 3D printer to handle multiple filaments. In a filament management system, the device can retract and automatically load different color filaments. And can do this as often as you want. There's a gotcha. In the case of the CFM, depending on the filaments you're using, it takes about 1 minute and 15 seconds to maybe 1.5 minutes to switch filaments. So every time on this little bear, when I was printing a layer that had yellow and then black and then white, I had to switch filament from yellow to black. That takes, let's say, 1.5 minutes. I have to switch from black to yellow, 1.5 minutes. I have to switch from yellow to white, 1.5 minutes. I have to switch from white to yellow, 1.5 minutes. We're already up to 6 minutes of switching time. So if I have to switch a number of times on a layer, we could add minutes to that layer. If I'm printing at 0.2 millimeter layer heights, that means for every millimeter of print where I have to do that, I have to do that 5 times. I could add 30 minutes or more to switching time just to print a millimeter high section of my print, which is why this print went from 30 minutes to 1.5 hours by adding color. However, this print did not. This print added about 3 minutes to the total print time. Why? I printed it like this. And therefore, each layer only had a single color. The printer never had to switch colors between layers. So it had to switch one time here, then I had to switch one time here. So I had 2 filament switches in order to print that print. That same technique can be used for signs like this. That same technique can be used for signs like this. But what's the trick here? Each color is at a different height. If I had the white and the red at the same height, I'd have to switch very often. But if you look at this print very closely, you'll see that there's a black base, then there's a white layer. And in fact, there's white printed under the red, and then the red is the final layer. So I switched from black to white, 1 filament switch, let's say 1.5 minutes. White to red, a minute and a half. So I've added 3 minutes to the total print time to print this 3-color print. So by properly configuring your prints with a CFM, a filament management system like the Creality Filament Management System, I can print lots of different beautiful, beautiful prints, adding almost no time to my print time. And as we look at these prints in more detail, I'll show you exactly how to do that. Now, let me discuss the Creality Hi Combo system. It really consists of two discrete components: the Creality Hi 3D printer and the Creality CFM, Creality Filament Management System. Working together, they allow you to print multi-color prints seamlessly without any user intervention. But they do more than that, because working together, they also create an environment where more prints succeed. It starts with the integration of the CFM with the new Creality hot end and extruder system. Let me show you a very quick video here of loading filament into the CFM. The CFM makes it much easier than it's ever been before to load filament into this Creality system. The new print bed that comes with the Creality Hi is listed as an epoxy-coated spring steel. The only disadvantage I found to this print surface is sometimes it sticks too well. If that happens, a trick you can use is to get the surface very cold. Literally take the surface with your print, put it in the freezer, and in a few moments, your print will pop off. But a better alternative is to follow the Creality guidelines, which say to always use a release agent. They recommend just using a glue stick, but I found that Magic Goo, a special formulation that sticks better when it's hot and is made to release when it's cool, works even better. Now, this print surface slides into guides on the Creality Hi printer, another thing that was often difficult on earlier Creality models. Now, let's go through the list on this slide of some of the other key features. Now, the first thing you'll notice is this printer auto-calibrates. All the days of leveling the print bed with a sheet of paper and getting it just right are over. If you go into self-test mode, it does 3 things. It levels the print head, it adjusts the filament cutter so that when you're changing filament, it cuts off the filament properly, and it uses a vibration sensor to do input shaping. Input shaping is the ability in Klipper to optimize the movement of the print head based on vibrations that occur for different types of movement of your printer. Now, you should rerun this self-check anytime you move your printer, because the characteristics of the table it's on will make a big difference as to the vibrations that are sensed in the input shaping algorithm. At the business end of the printer, it has a new nozzle design that's based on the high-end, the K series from Creality. We saw a similar nozzle in the Ender 3 version 3, but it's a little shorter. So this is the same length as the K2 Plus, and so you cannot interchange nozzles with this printer with the Ender 3 version 3, but you can with the Ender K2 Plus. The tip of the nozzle is hardened steel, so you can use abrasive materials. It's surrounded by brass, and there's a heat sink all the way up this section here that will minimize the heat creep, because what you want to have in a 3D printer is you want the filament to come out hot at the end and then be cool as quick as possible so it doesn't clog up in the nozzle. This is an integrated unit, So you don't have to worry about whether you tighten it in all the way in order to make sure the filament does not leak out the side. Because at the end here, where the filament does enter, it's completely cool. Next, the gears in the extruder are all metal. So you'll have less wear and tear and more precision. Now I saw that when I printed these Kickstarter sample prints, and I noticed that all of the test plugs came out cleanly, which speaks to the quality of the extruder are very, very good on this printer. Next, in the print head, in the new print mechanism, there are three things that we haven't seen before. The first is that you have a filament runout sensor in the hot end. Next, there's a filament cutter. That means we can cut off the filament, retract the filament, but then there's filament left in the hot end. So this printer knows how to extrude that filament into a waste bin. This is the waste bin from my printer for the last couple of weeks. And each one of these is cut off filament that was extruded out the end. So it cuts the filament, it retracts it, and extrudes the leftover filament. Then it inserts the new filament into the hot end. It extrudes some more, cuts it off at the end, and it's ready to start printing. Now, this basket actually was on the SD card and one of the first prints I made for this printer. It's just a beautiful, beautiful print. Now, let's talk a little bit more about the CFM. The CFM is interesting because it supports both Creality RFID encoded reels of filament and any standard size reel of filament. So I have freely mixed regular filament with Creality filament for many of these prints. A matter of fact, the black on the base here was a non-Creality filament. The white and the red are Creality filaments. When you load a non-Creality filament into the CFM, you go to the front panel on the printer in order to tell it what's in that particular slot. Let's wrap up by talking about the front panel a bit. The front panel is very complete. It's basically an interface to the Klipper software that is driving the printer. But I'm not a big fan. It's relatively small, and the touch interface is a bit finicky. So if there was one area that I would upgrade on this printer, it would be that front panel. And I'd upgrade it with a little bit larger front panel and a little better touch interface. Now let's look at the ways you can print to this printer. It's quite flexible. You can print directly from a USB key, from a thumb drive. You can print from Creality Cloud. You can print from the Creality app. You can print from Creality Print. You can print from a browser by accessing Klipper directly in this printer, and that's open for use. You can print from the printer's local memory. So it's a very flexible environment. Anyone who has any concerns about integrating with Creality Cloud for security or other reasons, you don't have to. You can print locally a variety of different ways, and you can print directly over your local area network from Creality Print. Let's take a look at how I produced some of these prints that are here on the screen. And first, to begin with, the print quality is good. I would say it's A-. It is not the absolute best I've ever seen, but I haven't spent a lot of time tuning it. I believe it has good bones. That is to say, I believe it is possible to get A+ prints out of this printer. It does require, just as it does with any other printer, that you fine tune it. So I'm going to get started by looking at why, by just adding a little bit of color, the white and the two black eyes, this went from 30 minutes to an hour and a half. So let's look at that together. And the best way to do that is to go right into Creality Print. So I'm going to open up Creality Print, and I've used it on a MacBook Pro M1 Max with lots of memory, and I'm using it right now on a Surface Pro 12, which is an ARM-based Windows machine, and it runs well on both environments. So let's first look at this overall screen to see how it's laid out. You'll notice there are often little arrows here. So a little arrow like that, the double arrow, indicates something that you can compress down. Now, it's not completely consistent because in this case, it's a single arrow. You'll also notice that there are tools across the top and that I can scroll to see more tools. And many of them are not currently highlighted because they will highlight when they're available. This is very similar, almost identical to the user interface with some things moved around that you would see in the Orca slicer. Over on the right-hand side is where you'll see things get a bit different. Because if I click on the device tab over here, and I look at this particular device, we'll see we're now connected to the Creality Hi. Now I'm going to go actually back here to home, and I'm going to take and remove this device to show you how easy it is to add. Now, the first time you add a device, you're probably going to use the Creality phone app. It's the easiest way. You get a QR code on the screen of the printer, you scan the QR code, it adds the device. But once that device is on your Wi-Fi network, and that's used to add it to the Wi-Fi network, I can scan for devices on my network. This is important because depending on your router and the configuration of your network, sometimes if you turn the printer off for too long, too many days, it will change IP addresses. So I'm going to take and do a scan add here. And you'll notice it comes up over here, and I can just click on the plus. And now that printer is on my network. Now, you can have multiple printers. You can have multiple printer profiles. So I found that because my prints were sticking almost too well, I wanted to add a little bit of Z offset to my prints. So I have a profile here called Z offset. Well, let me show you how I did that. So I'm going to click on the pencil here, and I'm going to click on advanced, and you'll see right up here on the top, it says Z offset. And if I mouse over, it'll tell me exactly what that is. Now, a sheet of paper is about 0.01 millimeters. So this is just slightly thicker than a sheet of paper worth of offset above the print bed, so that I have a little less squish that'll smooth out my first layers, and it will make it easier to remove my prints. And then I went ahead and I saved that. So this is where you configure your printer. Over here, you configure your print. Now, the items that are important to look at are if you click on this icon over here, you enable advanced parameters or not. We're going to not need to really change any of these things for these prints. And I really didn't change anything from the default profile other than deciding where I wanted color. And I'll show you how I did that. Now, one special part of this particular slicer is it is integrated if you choose to use it with Creality Cloud. So I can click on the Creality icon over here on the corner, and now I'm looking at Creality Cloud and at different models that I could either purchase or download and use. So let's just take this dog as an example and click on it. And we'll see that that dog, and if I go ahead and slice this, we'll see it's going to take a total of 1 hour and 1 minute, and it's going to change the filament 24 times. Now, that's changing the filament 24 times just to add those black eyes. Why is that? Well, we remember, if we look at this, if I look at this from the left and we look at a particular layer, we'll see that it's going to print brown, then switch filament, black, switch filament, brown, switch filament again. So there is 1, 2, 3 filament switches for just that layer. That's 0.2 millimeters worth of this dog. Anytime you add color in the middle of a layer, it's going to cost you time. Now let me demonstrate that to you specifically, because I'm going to go over here and I'm going to click on objects. Let me get this out of the way so you can see this a little bit better. And you can see here are the different colors that were indicated for various layers. I'm going to take these black ones and I'm going to change them to brown. We have the same dog, but it's all brown. So it did take, what, about an hour to print? Now let me slice it again and see how long it's going to take now. And now it's going to take half that time. So I cut the time in half by taking out the color because of the switches on the individual layers. So how do I take a single color object and print it in multiple colors and do it quickly? Well, for that, let's take another example. So I'm going to get rid of this object. I'm going to go back to prepare, get rid of this object, and now I'm going to go to a website produced by Make with Tech for our viewers, just to make it easy for you to find models. And it's called models.makewithtech.com. So I can go to models.makewithtech.com. Now, what's unique about models.makewithtech.com is not only are all the models free, there are only about 1,000 models. Many other sites have tens of thousands of models, or Thingiverse has over 1 million models. But every model is customizable. So let me take and search for a vase. And let's pick this one down here. And I can do a 3D preview of what that would look like. Now you'll see this is solid. Well, if I was printing in a single color, I could print in spiral vase mode, which is a single wall all the way around. But if you want to be able to change filaments, you have to have multiple walls. It's one of the requirements of the printer. So one of the things I'm going to change down here is I'm going to say that there's a wall thickness here that we're going to add. So let's make it we'll make it 1 millimeter thick. So 1 millimeter thick would be, since it's a 0.4 millimeter nozzle, about 2 walls. So now if I preview this, we'll see now it's actually a vase. But let's actually change this even a bit more. Let's say that we want to make the vase quite a bit higher, 120. And let's make the neck at the top pretty narrow. Let's make it 40. And let's see what that's going to look like. And so now we have quite a different vase here. And this is exactly what I had in mind. So once you have the vase or whatever you're modeling in models.makewithtech.com the way you want, you take and generate. And that will produce something ready for your 3D printer. And you can produce it in different formats. For a 3D printer, you'd use STL or 3MF. We'll use STL for right now. So I'm going to click on Generate. And this is going to queue this back to the Amazon cloud where the software runs. And you can see that didn't take very long. And now we have our vase. And the difference here is now I can actually download it. So let me take and download that to my computer. And If the creator of this vase and all the models on this site are coded in a special 3D coding environment called OpenSCAD. And it's a very, very powerful environment. And I've just sort of front-ended it to make it available. OpenSCAD has been around for many, many years. It's an open source project. So now that I have that available, let me go to my Creality print utility. And we're going to load that in. So I'm going to go to downloads, and here's my vase, and I'm going to open it up. And you'll see it's automatically mapped to the first color. But if I chose to, I could go to that object there, object number 1, and let's make it white instead. Or I can make it yellow. And when I go to print this, the printer is going to automatically utilize the right filament from the filament management system. So if we take and we look at this model, we can see how it would print. So I'm going to go ahead and slice this. And we see this is going to take 1 hour and 2 minutes to print. Not too bad. But I want to change the color in the middle. So let's say I get to a point where I want to change the color. I right-click on the plus and I say change filament. Let's put a blue stripe in the middle. Now let's go up a little ways, right-click, change filament, and we'll change it back to yellow. And go up to the top. Now let me reslice this model. And you'll see now it's going to take a little bit longer because we're changing the filament 3 times. We're changing it initially is 1 time because we're not using filament number 1. Then we're changing to blue. Then we're changing back to yellow. So that's 3 times. So this is going to automatically print this multicolor vase. Because we are changing filament, it's also going to print a waste block, a tower on the side, where it will ensure that the filament color has been fully purged. Now, if we want to, because we know that it's really not going to matter for this particular print, we can go and turn that prime tower, that waste tower off, slice again, and now we can see it's going to print even a bit faster. Now, once I've done that, I click on Send Print, and this will send the print automatically to the printer. Now, that's how I printed this one, and that's how I printed this one. I just changed the filament. Okay, now I'm going to show you how you would print this multicolor print all as a single print at a single time without any user intervention. So we're going to go back to models.makewithtech.com, and this time we're going to select customizable toy car. And we could click 3D preview here to see what the default car would look like. And we can see here that it's a squarish car and the parts are laid out separately. But what if I want to see that all put together? Well, I can scroll down here to the parameters, and I'm going to say that now I want to look at it in fully assembled mode. So what's this going to look like? And I can look at the 3D preview, and here I can see it fully assembled. Well, that's not very interesting. Let's make this a race car. So I'm going to go down here, and I'm going to choose Vintage Race Car. And now I can click on 3D Preview. And there we have a race car. Now I can change the size of the wheels. I can make the back wheels bigger. Let's do that, in fact. Let's see here. The rear wheel size, let's make those extra large. Let's make the front wheels extra small. Let's see what this looks like now. And the purpose of this video is not to teach you how to use models.makewithtech.com, but you get the idea. So now I'm going to take and switch it from fully assembled to single build. Let's verify what that's going to look like. And you'll see here that I have the hubcaps, I have the tires, I have the car, each in a different color. And that's going to be very important because I'm going to use those different colors to separate these into parts and then to assign different filaments. Now, the colors I select here don't really matter. What matters is that I'll be able to select the separate filaments for those. So I'm going to generate this, but this time I'm going to generate it as a 3MF. The reason for generating it as a 3MF is 3MF files can maintain color, STL files cannot. So I'm dispatch that to Amazon, to our hosted version of OpenSCAD, and it's already finished. And we can review that here now. But I'm going to need to do one extra step. Now, while this 3MF file has color in it, it does not have the different sections, the different colors separated into different parts. I'm going to want to separate them into different parts so when I slice it, I can, instead of printing by layer, I can print by object or by part. So I'm going to click on, see this little palette here? This is a special function built into models.makewithtech.com that will take a 3MF file. It will divide it into parts based on color. Now, there's a caveat. The colors can't touch. If they touch, there are problems in dividing it. So I'm going to say continue. And now you'll see the icon here changed. And now I'm going to download that file. And let's go back to our slicer. So let's rotate this so we can see it in the front here. And I'm going to take and import that file. That now we have 3 different objects here. So I can leave the first one in blue. I'm going to make the hubcaps white, and I'm going to make the tires red. Now I'm also going to make a couple changes here. The first change I'm going to make is I'm going to click on global here, make sure I'm on multicolor, and I'm going to turn off that tower. We don't need it. And now I'm going to go all the way down to other and special mode, slice by, not slice by, but print sequence, print by object. Now I'm getting some error messages here, and the reason is my objects are overlapping. So if I look at this here, see where the circles overlap? Well, I need to move them so the circles don't overlap. And I don't know if I'm going to be able to actually do that here. Let's see if that's good enough. No, they're all too close together. So in this particular case, the size is a little too close together. 3 is too close. Let's see. Well, maybe we're all right here now. So now let me try to slice this. It seems object 2 has floating regions. So we could turn on, that's object 2, we could turn on support. So I'm going to click on the hourglass and look at supports, support type, enable support. Now let's slice this again. Okay, and now it's going to tell me that it's going to change the filament only 2 times. That's because we're going to print an object, change the filament, print an object, change the filament, print an object. And it's going to take a little less than an hour to print this. So let's actually see how it would actually print. So if we go here, we'll see it's printing the first object completely. Then it's moving over, it's printing the next object. Then it's printing the third object. So by turning on the special feature here, which is print sequence. And by moving these so that they don't overlap, see those circles? So the circles don't touch, but the circles can go outside of the print area. I'm now able to print these objects all at the same time. So I printed this car in about an hour, then I assembled it with a little bit of super glue and a couple nails for the axles. Well, folks, I hope you've learned something today. You learned about the Creality Hi printer, very solid printer that just works. You learned about printing where you change colors within the layer and printing where you change colors between the layers. And there are many, many more possibilities for how you can use the Creality slicer or any Orca-based slicer in order to colorize your prints and print them on a printer with a multi-filament management system such as the Creality Hi. Have a great day, and let's continue to learn things together.